Okay, Gab.
Merci, Charbel. Alors, bonjour à tous. Good morning, everyone. My name is Kevin Delarosville, Director of Communications of Aéro Montréal. I am very pleased to be your host today on behalf of Suzanne Benoit, President of Aéro Montréal. I want to thank you for joining us today for this webinar under the theme, Can Government Make Aviation Sustainable? This event is the second of a new series of webinars proudly organized by Aéro Montréal in collaboration with a longtime and valued partner, Aviation Week. We are very fortunate to welcome a wide range of experts who, I'm sure, will be most interesting. So with us today, we have Graham Warwick, Executive Editor for Technology at Aviation Week, Alexandru Jordan, Chief Technical Officer and co-founder of SAF Plus Consortium, Anna Stukas, Vice President Business Development at Carbon Engineering Limited, Fassi Kafieke, Engineering PhD, Fellow, Research, Innovation and Collaborations at Bombardier, and Jean Thomasin, Senior Director, New Product and Service Introduction at Pratt & Whitney, Canada. Thank you all for being with us today. We truly appreciate it. So as you know, the current health crisis has presented many challenges to the world as a whole. The pandemic has forced societies to rethink how they live, learn, work, and play. With many challenges, opportunities can present themselves. This rethinking process allows us the chance to address issues that are important, but were not necessarily being universally treated as urgent. Our focus here today in this webinar and every day in our ecosystem is to combine the sense of importance and urgency and address social and environmental issues of sustainability within our industry. With balanced collaboration between our leading industrial innovators, some of whom I'm proud to say are here today, and the different levels of governments in Canada, lies the opportunity to accelerate the commercialization of cleaner technologies to dramatically reduce aerospace's carbon footprint. The industry will and is advancing on its own. But to truly seize the opportunity we have before us today, the government needs to set and participate in a playing field that will facilitate and especially accelerate the change that societies around the world are expecting for the environment. Canadian industry and government can help shape that reality. So today we can learn how. So now, before turning the floor over to Graham, I would like to briefly walk you through the technical details of this session. So first of all, please note that all microphones have been turned off to avoid any background noise. If you wish to ask a question during the Q&A session at the end, you will have to submit it in writing. To do so, please click on chat or clavardage and ask your question to the host, Aéro Montréal, or to all if you wish your question to be public. The session will be held in English, but I very much encourage you to ask your questions in the language of your choice. Cette session aura lieu en anglais, mais nous vous invitons à poser la question dans la langue de votre choix. On this note, Graham, the floor is now yours.
Thank you very much. As Kevin said, aviation has been hit hard by COVID-19, and the focus for now is very much on survival. But climate change has not halted, and the pressures on aviation to be sustainable are returning quickly. However, aviation is widely acknowledged to be a very difficult sector to decarbonize, largely because of its dependence on fossil fuel to give aircraft the range and performance that they have. But it's also hard to decarbonize because it's a very complex global system with many moving parts that must be synchronized if the industry is going to move in a particular direction in a harmonized way around the world. If we leave it to individual parts of the system to decarbonize at their own pace, with their own resources that they have available, we'll never get to where we need to be, which is widely talked about as being, net zero by 2050, but people have actually started to talk about really wanting to see a big delta by 2035, which is not far away in aviation terms. Because of this, it's pretty clear that governments need to play a role across support for R&D, policies, legislation, and other leadership actions that help all parts of the aviation sector. Now, Canada specifically is an extremely multicultural society that relies very heavily on aviation to connect people not only across a huge country, but also globally, because so many people in Canada come from so many different parts of the world. Canada is also a country that looks to its world-class aerospace industry to generate high-value jobs and high-value exports that support the economy. Now, other countries have shown that they understand the value of air travel to their societies and the aerospace industry to their economies. So I want to, if I could just go to the first slide, please. I want to just show what some other regions and countries are doing now to help aviation become more sustainable. So we tend immediately to always look to Europe because in many ways they are a leader when it comes to things like the environment. So they have a number of initiatives underway now, which are directly intended to provide support in various forms to the aviation industry to become more sustainable. So there is the Refuel EU Aviation Initiative, which is to bring in policies, legislation, and other incentives to boost both the supply and the demand of sustainable aviation fuel in the European. Now, they've just closed the consultation period on that, and the European Commission is supposed to adopt that in the fourth quarter. So they will then know what sort of things the European Commission is going to put in place to help build that supply chain for sustainable fuel. Europe's also announced the Hydrogen Alliance, which is across every sector. I mean, it's every industrial sector, the energy sector. It's about moving to hydrogen as the energy carrier of the future, the zero emissions energy carrier of the future. But obviously, aviation is going to play a role in that. And the Partnership for Clean Aviation, as it's called now, is the process they're going through to create what we would call Clean Sky 3, which is a European-funded, multi-year civil aviation research program that targets high-level goals. It says we want to reduce emissions by this, travel time by this, and then under that, they put a joint industry and government money against those goals, and under that, they fund projects that drive the industry towards those goals. They are in the process of defining what that third multi-year program, 21 to 27, will look like. Decarbonization, hydrogen, electric propulsion are all going to be big parts of that. And it will be billions of euros that will be put against that over that period of time. France has gone very aggressively in a stimulus package, post-COVID stimulus package, to provide support for its industry. Now that support comes in various forms, but one piece of it is specifically to invest 1.5 billion euros by 2022 in R&D that would help develop a net zero carbon commercial aircraft by 2035, something that Airbus is committed that it will do. It hasn't said how it'll do it, but it's committed to do it. And they have just, France has literally just released its hydrogen strategy to move to the hydrogen as the energy carrier. And again, aviation is specifically called out in that as part of, included in the piece of that would fund the technology to move aviation towards using hydrogen in whatever form it can be used. Germany similarly, back in before pre-COVID, they put out the Leipzig statement, which was really their government level commitment to moving aviation towards sustainability, which included, interestingly, a commitment by the government to use aviation tax revenue to support aviation research for climate-friendly aircraft and propulsion. Now, in many countries, aviation tax revenue goes into the general fund and then gets used in whichever way the government chooses. Does not often come back to aviation as a support mechanism, but the government said it would change it would reform its tax system to to have aviation tax pay for aviation R&D to make aviation more sustainable. And then obviously Germany has done, similar to France, has done a big stimulus package for the industry. Aviation is part of this 15 billion package of R&D support that's aimed at low carbon transportation. So that's roads and ships and other things like that, but aviation is specifically targeted to get R&D support to move to low carbon transportation. Next slide, please. Oh, UK, sorry. Okay, moving to the UK, no longer part of Europe. They've done a couple of things. One is they formed the Jet Zero Council, which is a very high level coalition of government ministers, aviation and other businesses, industry associations, and the environmental groups. And really what they're trying to do is align aviation with the UK's stated goal of being net zero by 2050. Now, one piece of that that's already become out is a thing called Fly Zero. Fly Zero is a 2-year, £50 million project led by the Aerospace Technology Institute, which is bringing together about, I think it's about 100 experts from the industry to basically lay out which technologies the UK industry has to develop in order to play a key role in developing a zero carbon aircraft by 2030. Now, they're not saying they're going to develop that airplane as an industry, because the UK industry, by and large, is a collaborator these days, but they want all the pieces of the UK industry to be able to put technology forward to a zero carbon aircraft, wherever that's being developed, whether it's Airbus or other things like that. Scandinavia, obviously, you know, it's a leader when it comes to the environment. And so Norway was the first country to mandate the use of it's a blending mandate of sustainable aviation fuel. It's very small at first, just to get it going, but a target of 30% by 2030 means needs a significant scale up in sustainable fuel production to get there. As you can see, Sweden is going to follow with its own mandate, which looks very similar. Finland has a similar mandate. All of those mandates, if they carried through with, require a very large increase in production, but they also provide a government mechanism to incentivize and stimulate that increased production. Electric aviation is the other one where the Scandinavians are moving quickly. So Norway said it wants to begin electric domestic flying in 2030, and it wants all domestic flying to be electric by 2040. Aviation is key to moving around inside Norway. There are like 40 airports, and they're all just, you know, tens of miles apart maybe, but they're on the other side of a mountain or a field. They're absolutely essential, but they've said we want all electric by 2040. Sweden is moving in a similar way. They want to begin short-haul electric flights by 25, and Norway, Sweden, and Finland are actually now trying to work out if they could come up with a joint electric aviation network. So, and then the other thing that's happening in Scandinavia is that with the abundant renewable energy, whether it's hydroelectric or wind, there's been 2 projects. These are commercial projects, but they're built on the country's investment in renewable energy to build very large renewable fuel production plants that take the renewable electricity and turn it into sustainable fuel, liquid fuels of different forms. So I have not included in the US in this because it doesn't operate the same way, but if you actually go through, you will see that the government has over time provided significant financial support through the US Department of Agriculture to build feedstock pipelines, through the Department of Energy to develop new pathways for making sustainable fuels, and now they're also investing in electric aviation. And obviously NASA has a long connection with electric aviation, and it has a flight demonstrator program coming up. So, and then you have the low carbon fuel standards that are in Oregon and California, which are already, you're seeing that they are pushing the refiners, the fuel companies to move to renewable fuels in those states, and the airlines to sign offtake agreements for renewable fuels in those states. So that mechanism is clearly having a response on the market. So we see therefore what the rest of the world is doing. So, you know, when it comes to Canada, it would seem to me that the question is not whether the Canadian government should help aviation become sustainable, but how it should help the aviation become sustainable. And as for the how, or the how's probably plural, we're now going to hear from experts across this complex aviation system, from carbon capture and fuel production, engine and aircraft development and manufacture, to the aviation ecosystem of airlines, airports, and fuel suppliers that allow us to travel around the country and the world. So we're going to begin with Anna from Carbon Engineering. Over to you, Anna.
Thank you, Graham. And next slide, please. So for those of you who haven't heard of us, Carbon Engineering is a Canadian clean energy company focused on the development and deployment of climate relevant carbon removal from the atmosphere. Our technology, called direct air capture, has the ability to capture dilute source carbon dioxide from the atmosphere, at which point you can do one of two things with it. You can either put it back underground where it came from, or you can combine it with low carbon hydrogen to produce drop-in compatible sustainable fuels. So if we take a step back, and as Graham has mentioned, there are numerous challenges to decarbonizing aviation. And if we were to hazard a guess at what the ideal solution for decarbonization might look like, there are a few necessary components that are critical for any solution to get to net zero. In particular, any solution needs to be fully scalable. It needs to be suitable for global deployment, recognizing that it doesn't work to have an airplane that is configured to take in one type of fuel in one jurisdiction and then fly to another jurisdiction where that type of fuel might not be available. You need technology that's proven, you need cost optimization, and ideally, although I'll leave this to Pratt & Whitney and Bombardier to comment on, it would be non-disruptive. It would be compatible not only with existing engines and aircraft, but also with future ones. The challenge of backwards compatibility is a huge one when you consider the lifetime of your average aircraft. We'd be looking for solutions that minimize both direct and indirect environmental impacts. And importantly, that can help us get to net zero on a full life cycle basis. So that well-to-wheel accounting and ensuring that we're looking at that full life cycle carbon intensity, not just whether you've avoided some emissions temporarily. So Carbon Engineering brings two potential solutions that are complementary to the aviation industry. The first is permanent carbon dioxide removal, where the ability to decouple the point of emission from point of collection by using direct air capture and sequestration allows you to decarbonize aviation without any changes to the aviation industry. Now, this is not a silver bullet. This is not the only solution. It is one tool in the toolbox that can be used. Adding into that is the ability to directly decarbonize by using sustainable aviation fuel that can be produced by combining atmospheric carbon dioxide with that ultra low carbon hydrogen. And when you do that, you can get to near zero carbon intensity in the fuel that's going into your aircraft that is near drop-in compatible. It's already approved under the regulatory processes. And if anything, it's cleaner burning, comes with a higher energy density, and can help to reduce other elements beyond just carbon dioxide. So if we can flip to the next slide. So our products and what you see there on screen is low carbon crude that has been produced by our pilot plant in Squamish, British Columbia. We've been capturing carbon dioxide from the atmosphere since 2015. We've been turning that carbon dioxide into ultra low carbon fuel since 2017 and are currently in the process of constructing and developing a permanent innovation center that will allow us to transition to 24/7 operations on a larger scale. So the low carbon fuels that we produce, because we're using recycled atmospheric carbon dioxide and renewable electricity, we get a carbon intensity on a full life cycle basis that's near zero. And it can be refined into diesel, into jet, or into gasoline. And in fact, as we speak, some of our atmospheric crude is currently being refined into sustainable aviation fuel as part of Natural Resources Canada's Sky's the Limit challenge. One of the particular advantages, and biojet has been around for a long time. Biojet is a wonderful part of the portfolio of solutions that we need to look at. But when you look at the feedstock coming from the atmosphere and coming from renewable electricity, instead of from conflicting perhaps with food needs, that greatly contributes to the scalability of your solution. In addition, because we're creating our fuels from pure carbon dioxide and hydrogen, there aren't any of the other materials that you get when you pull your fuel out of the ground. So there's no sulfur, no particulate matter, no aromatic hydrocarbons. And this means that they're much cleaner burning. And what you see in the call-out box in the top is a comparison of our fuel burning compared to conventional diesel. And importantly, you'll see that there's no black smoke. In an aviation context, we believe this will contribute to lower formation of contrails, which can also help to reduce climate change impacts. And this fuel is wholly compatible with existing aircraft engines without modification. It's already approved under the regulatory standards for blending up to 50%. And we believe that through partnerships with engine and aircraft manufacturers, that we can move towards 100% compatibility. So looking forward in our future discussion to talk about how we can incentivize adoption of solutions like these, particularly focusing on the need for performance-based standards that reward low carbon intensity, looking at opportunities for government procurement, and then looking at mechanisms such as the 45Q tax credit in the United States that help to backstop some of the market uncertainty in those nascent regulations. So with that, I'll turn it back to Graham. Thank you.
Thank you very much, Anna. Yeah, interesting that you point out you mentioned biojet. I mean, the aviation industry moved very quickly, actually, for a sector to develop the ability to use sustainable fuels. It's just been a very long process to get those to any level of commercial. But not just that. As you point out, the indirect effects have proved to be quite vexing. The getting sustainable fuel that doesn't have indirect impacts, and aviation has struggled with that. I mean, if you look at what ICAO's done with Corsia, there was a very long process of trying to work out, which things are you going to put backing into that don't have an unintended effect. And it's very interesting what you say about your fuel that avoids many of those things that have actually held the industry back in the last few years. So, so it's a very interesting time if you're an engine manufacturer at the moment. I do a lot of writing about electric propulsion, advanced turbine engines, and I'm now having to sort of learn all about hydrogen and different fuel cells and fuel cells. So I feel a little sorry for the engine manufacturers at the moment. They've got a lot of balls in the air that they're trying to make a choice. So our next speaker is Jean Thomasin, and he's going to give us the engine developers' viewpoint from Pratt & Whitney Canada. So Jean,
thank you, Graham. So let me just introduce a little bit what is Pratt & Whitney. Pratt & Whitney is a part of a big family. We're making big commercial engines. You see in the middle the single aisle GTF engine. We also have a military side to the house. And Pratt & Whitney Canada has the full product portfolio for the, say, less than 15,000 pound thrust engines. It sort of sweeps a broad portfolio of products between helicopters, auxiliary power units, general aviation, business aviation, and regional as well. That's the company. Next slide, please. In terms of sustainability, the objective of, or the vision of this corporation is to becoming the best aerospace company for the world. So just an example, you know, improving thermal efficiency. So at the end of the day, we hear about electrical flight, we hear about potentially fuel cells, hydrogen, and we'll talk to that a little bit. But at the end of the day, we convert heat into mechanical power, mechanical work, and thrust. And improving thermal efficiency is sort of like a second nature. Our latest product is the gear turbofan engine. It's in the 17,000 to 33,000 pound thrust class. It brings a 16% fuel burn reduction, carbon reduction, 50%, 50, in regulated NOx reduction, 75% in noise. That engine is out in service for a few years now, but it's been worked on for decades with partnership with governments. So if you go to the next slide, now talk about sustainability. What's the situation? So I think you have to click a few times to get the full display. So think of sustainability. You know, you may think that zero emissions airplane is not possible, but you know, it can be possible. But look at the situation now for us. You know, the base business is going down, and we see all these new technology coming at us. But we need to activate, because we are competing not only against other companies but against other countries. So to sort of try to answer the big questions of this conference here is that what is it that Canada can do? So it can partner with the industry and have some sort of a focused Monte Carlo approach. Because, you know, what's going to win? Electrification, hydrogen, fuel cells, better heat engine. I don't think there will be a silver bullet in there, but there will be a combination of things. Electrification may help to bring new capabilities. So that's the reason why the solution here is that Canada, when you think of it, is we are punching above our weight in that industry versus, you know, the size of the country versus what we bring to the table. So if we could just acknowledge that, make a statement that we will emerge as a leader into green aviation, that would be a big step forward. With that, I'll return it to Graham.
Thank you, Jean. You make an extremely important point that we must not forget in all of this, is that we can talk about sustainability, we can talk about new technologies, but the underlying trend in aviation has been for decades now is increasing efficiency, reduced cost of operation. While you know, there are going to be cost implications of sustainability, we cannot lose sight of the fact that we must continue to make the products more efficient, more affordable, while we also make them more sustainable. And we can't lose sight of that thread that has stood us so well for decades, because it will stand us well for decades to come as well. So and now for the I'm going to hand over to Fassi for the aircraft manufacturers' viewpoint. And again, that efficiency has to be a big part of what you guys are focusing on.
Yeah, absolutely. And our vision, of course, is to create better ways to transform how millions of people travel every day. Aviation is absolutely necessary for the economy of the world. And so it's not going to stop. So we need to find more efficient ways. So there are three objectives that guide our approach. First, we have to ensure the compliance to all the environmental regulations. Two, we have to strive to improve environmental performance of our products and of our operations. And then we seek to lead the industry in this change. Next slides. So if we look first on the environmental compliance, the key action we had to take was to manage the materials and substance of concern and to respond to external requirements, whether it's our suppliers or our customers. So for that, we had to implement effective management system for controlled substances such as REACH. and materials. So that allows us to know much better what is inside our product. And then we have to increase environmental transparency and communications, both with our suppliers who give us the data and our customers who ask questions. And in terms of operations, all the eligible sites are certified or in the process of being certified to ISO 14001 environmental management system. Next slide. So this is the next important thing is to improve the environmental performance of both our operations and our products. So the key actions, of course, are to develop greener technologies, to lower the impact of our existing product and operations, and to improve the product's end-of-life management. So first on the product itself, environmental sustainability is at the core of our product innovation strategy. 80% of the environmental impact of aircraft are determined at the design stage. All new products are now designed following eco-design principle to apply a life cycle perspective, reduce emissions, maximize recyclability and recoverability, and eliminate hazardous substances, invest in technologies and involve suppliers. Today, 85% of our products, of the materials in our aircraft are recoverable. We have an aim to reach 100% recoverable by 2025. Also, if you look at an example, thanks to the redesigned wings and the brand new purpose-built Rolls-Royce Pearl engines, the global 5500 and 6500 are up to 13% more efficient than the global 5000 and 6000 for specific missions. So this is the type of improvement for the environment that we can do with technology. Now, the next thing is to lead sustainable aviation fuel promotion and adoption of our industry, because that can affect all our current operating base. So through Bombardier Aviation, David Colliers, who is the chairman of the General Aviation Manufacturer Association's Environment Committee, Bombardier is leading industry engagement in development, commercialization, and adoption of sustainable aviation fuel. The general aviation industry is committed to continuing its important work in making SAF a regular part of flying business aircraft as part of our long-standing to emissions reduction. Our industry is ready to fly with SAF today, which is certified as a drop-in fuel. It is safe, it does not impact aircraft performance, and it doesn't require modification of the aircraft. So Bombardier is committed to help promote the increased use of SAF through the industry. And then, of course, we have to continue developing expertise and engage with industry to promote the end-of-life management. On our operations side, all the new buildings that we are putting up are LEED certified. We also joined the Western Climate Initiative Carbon Market, and we have strong environmental improvement in sites over the last 10 years. Next slides. So leading industry change, we're trying to showcase leadership throughout the industry engagement and to shape international environmental standards. So we engage the industry groups to solve environmental issues and drive climate change, climate action. We have strong engagement ICAO in various committees of CAPE, and we lead the life cycle assessment and environmental product declaration. As a matter of fact, Bombardier is the first company to introduce environmental product declarations to aviation. We did it first in commercial aviation with the C series, which is now the A220. And we have now done it for the first time in business aircraft. As on June 30th, the Global 7500 received the first environmental product declaration in business aviation. So this is a different level of transparencies with everybody in order to know exactly what is the impact on the environment of an aeroplane during manufacturing, during operation, and during end of life. And we are working actively with various industry and government bodies to do this. And I would say that in terms of government help, it's mostly in the improving the performance of our airplanes. You know, we have to make sure that SAF becomes cheaper, that it's more flexible, that we have some local suppliers and a better distribution, and government can help in that area. We also have to make sure that we develop technologies which will make our airplanes a lot more fuel efficient. We can go to 10, 15, 20% with various technologies, but it requires, as the Europeans are doing, collaboration between government, universities, industries, and most importantly, before we get any technology on an airplane, we have that very important demonstration phase, which is fairly expensive. And this is where we really need the governments to help in order to prove. There is a potential for Canada to have a branding of green products in aviation, because we already have many much potential in this area. So that's what I had to say at the moment.
Thank you, Fassi. And you make a very good point that when we talk about sustainability, we must remember we're not just talking about how we operate the aircraft, but how we operate our businesses. It is the whole system. Yes. has to do this if we're going to achieve goals. So our final presenter today is I think you probably say this is where the rubber hits the road. This is where the aircraft and the airport and the fuel come together, and we try to make air travel a sustainable equation and convince the customer that it is it's not flight shame, it is the right thing to do. So Alex, can you talk to us about SAF Plus Consortium and your approach to this?
Thank you, Graham, for this introduction. And I must say, I really appreciate and always amazed to see what's happening across the entire value chain. And what comes to mind today is that we have a saying when we raise a child, we usually say it takes a village to raise a child. And it talks to the complexity of doing that. Well, if I look at what it takes to make an aeroplane fly and to have a flight as a passenger, it somehow takes a mega city, I think. And all of us today are showing how important it is to have a value chain approach to sustainable aviation instead of a technology-centric approach, trying to change one technology with another, or somehow work in silos depending on where we are in the value chain. And this is the underlying principle at SAF Plus Consortium. We are, as a mission and vision, we are a technology and project developer. We aim to pioneer the production of domestic sustainable aviation fuel made from CO2 emissions. As such, we already have around this consortium stakeholders representing the entire value chain, where we have the technology providers, the underlying technology providers, people that are able to capture carbon or convert carbon like we're doing right here, the feedstock suppliers. In our case, is the people who are producing CO2. Right now, we will be producing CO2 from emissions captured from the industry, heavy industry, and I'll talk more about that later, but there's a place there obviously for direct air capture in the future as things progress. Also, we have fuel distribution. That is very important to figure out what you do with the fuel. You cannot have parallel supply chains. People in the aerospace and aviation know that very well. We're talking about engaging with the right original equipment manufacturers such as Bombardier or Pratt & Whitney. We actually had chances to talk both with representatives from these great companies here in Canada, but also elsewhere, to make sure everybody is aligned on the fuel specifications and how this will play in. And ultimately, if we really want the rubber to hit the road or the aircraft to take off, we need the airports and airlines to be there. And we are fortunate to have with us from the very first beginning Air Transat and Aéro Montréal as stakeholders here for our project in Montreal, as well as an array of stakeholders, as you can see from across the plane. If you can go to the next slide. So I was mentioning that unlike what we heard earlier, what we approach is a bit more hands-on, what we feel a bit more pragmatic way into using CO2 and actually recycling CO2 from industry emissions. So we take that CO2, convert it with the help of hydrogen produced with renewable electricity into sustainable aviation fuel at our plant that will be based here in Montreal. And so to obtain a drop in clean aviation fuel, which would be, it's already one of the pathways that were cleared through the ASTM process and at the ICAO in terms of a chemical perspective. And I'm happy to report back that as anything made out of CO2, we will share all the incredible advantages that Anna described earlier very well. I think she did an actual great job, as always, Anna. And with that comes, we have like a drop-in, almost a turnkey solution here on the ground. And based off of that, we've signed a first fuel offtake agreement with Air Transat. It was earlier this year. We're really excited about that because we're really talking now commercial terms. Our plant, our commercial plant is supposed to start operation in around 2025. If everything related to COVID is going to not destabilize that plan, but we feel excited because even though aviation right now is definitely, as Jean was saying, in a place where in a challenging place, we believe very strongly that things are going to come into some sort of normality. Is it going to be 100% what it used to be? It's going to be 120 or 80%? We don't know, but that normality will come up. And while we will end up in that normality, still having a 1 billion liters per year challenge in terms of fuel that has to be either reduced through efficiency by the engine manufacturers, aircraft manufacturers, reduced or replaced by SAF, or eventually compensated through offtake agreements. And if we go to the next slide, I want to say that right now where we are is we are in the middle of finalizing construction, fabrication of our pilot plant. It's already the carbon portion of carbon capture portion is already installed in Eastern Montreal on the side of Parachem Industries, and the conversion portion of it will be installed very briefly. We are also part of the Sky's the Limit Challenge. We were one of the finalists, and we are looking forward to next year's round 2 of that competition. Very excited about that. In terms of how the government can be involved, I think Canada already showed a bit of leadership in that. The Sky is the Limit challenge in itself, in the North American context, I think it's definitely a show of leadership. It asked for competitors around Canada to show a path forward towards commercialization of SAF Plus, and the 4 strongest projects or proponents, they received $2 million to get that to actual production. I think that is amazing leadership, and they took a chance, and I think they were lucky. They had at least four good candidates. We believe strongly that the way for CO2-based fuels is clear, and that we can show it in Montreal. Based on the carbon capture from industrial emission is even more simple to put in place and cheaper, at least in the first instances. Now, there are other places where we think it can be more, Canada could do more. The one thing is recognizing, as was mentioned earlier, that we need to look at all the different options right now, and probably look at different scenarios in which we will have kind of a mosaic of complementary solutions in place. I believe Canada has to have a roadmap for sustainable aviation based on those scenarios and on what can raise and all of that. In the States, there's ethanol, there's all kinds of other fuels. Canada does not have that kind of feedstock available, but we have others. We have renewable electricity and we have other fuels. So that could be in a pathway to hydrogen as well. The second portion is really looking into how government can stimulate demand. And I think offtake agreements are really important, and the government can show leadership by actually entering into offtake agreements with SAF producers here in Canada. And there's already a first step to the Defense of Canada, again, taken this year, where a request for information for offtake agreements actually has been raised, and SAF Plus was one of the companies showing interest into that and discussing with the government. That is not new. In the States has already happened for transportation and actually even for aviation fuel to some extent. So I think it's a really valuable way for the government to support this. And lastly, but I guess not least, is to support really that portion that is critical that Fassi was talking about, where we have to test, we have to certify either fuels or new technologies, where we have to have our first demo, if it's a demo of a new aircraft or for new engines, or if the demo is for a first of its kind plant like we're doing. But the government really needs to be there for that, because when the government is at the table, producers of technologies like that are able to also access finance a bit easier from private parties, which will help tremendously.
Okay, thank you, Alex. We've got about 10 minutes for questions here. I want to get kind of specific here on what the government can do. So Anna, you mentioned a number of at the end, potential things they could do. So, I mean, could you make some specific recommendations? But also, I want it in an aviation perspective, because several of you said that we need to take an aviation sector. We need the government to take an aviation sector approach to this. We need an aviation sector roadmap. We need an aviation sector leadership. So carbon capture, renewable liquid fuels are across all forms of transportation, etc. So I'd be interested from you both what the government can do, but also specifically with aviation. I mean, is there something that needs to be done specifically with aviation?
Absolutely, and I think, Canada has taken a lot of great initial steps. So as Alex mentioned, they've issued a request for information around clean fuels. The clean fuel standard is in the process of being developed. But we need to bring together a full portfolio solution. And I think some of the best examples of this can actually be found in California, where from an aviation specific perspective, the California Low Carbon Fuel Standard, which is a performance-based fuel standard that requires a reduction in full life cycle carbon intensity and is market-based, it's performance-based, that's gold standard for what we need to do. They've allowed for the opt-in of jet fuel, because they've recognized that initially, if they simply regulate it and there are no solutions, then that's not a tenable situation. So having the ability to create the mechanism that rewards the production of sustainable aviation fuel is critical, and does so in a way that is viable for the industry to participate in. The second piece that the US is doing through their 45Q tax credit is that they are rewarding the capture and use of carbon dioxide. And they're doing so in a way that provides a backstop against the market uncertainty of the low carbon fuel standards. So that helps. I mean, when you look at the plants that carbon engineering would be looking at making, or that SAF Plus would be looking at making, these are billion-dollar investments, multi-billion-dollar investments. A producer isn't going to be able to make that investment decision without some certainty on the revenue. And so that's where those two other pieces of the combination of a tax credit to backstop market uncertainty as the clean fuel standard comes into effect, and then governments participating in offtake to provide guaranteed revenue to these systems. And then ensuring that when you pull all of these things together, you recognize the complementarity. There's been several references to hydrogen, for example. Well, if you take one of our plants, if you were to produce 100 million liters per year of synthetic crude, you need over 100 tons per day of low carbon hydrogen. That's a huge draw for low carbon hydrogen and a kickstarter to the hydrogen economy. So the government can play a role in helping to bring all of those pieces together, but it's about having that entire ecosystem approach that allows producers to actually be able to press go on these significant capital investments.
Thank you, Anna. So Jean, Pratt & Whitney Canada specifically, I think, has one of the most challenging, positions in the industry, because you make engines that are used across the broadest range, from the small, we're talking here about commuters, regionals, short-haul transports, helicopters. So you now have a range of competing technology options in front of you. Now that could confuse the government. They may think that they want to pick the winners, but what can they do for you to help you approach that across your broad product base, to look at these technology options and be globally competitive? What can they do to help you?
Well, and Fassi brought it up, talked about demonstrators. I think if we have a focused demonstrator to scale, because many of these options are coming up, like electric power. Storage is an issue, but there's there are sizes and some configuration of the system where it can bring benefit. There will be a pull towards hydrogen, whether you consume it in a fuel cell or in an engine, is an unknown. But I think if we could have a flight demonstrator for all of these systems and all of these propulsion architecture, that could be there for different phases. And we have emerging technologies that are coming up and not ready to fly, but there are technologies in the TRL type 4, 3, 4, 5 that needs to be accelerated. So if there was a dedicated demonstrator, like for the long run, that could onboard these technologies, we could try them out. And it has to be to scale, because designing for a big airplane removes a lot of the constraints. So I think that's a practical way they can help is to help partner with us on some key demonstrator, focused demonstrator, but you almost want a Monte Carlo approach, because like you're saying, we have building blocks all over the place, but we need to size things and learn them out.
Can I have a follow-on question? It's a very specific question about electricity. Do you see electric propulsion as being going forward as a complementary part of your product portfolio, or is it competing in some way and you have to make a decision on?
Well, at the very bottom end of our product portfolio, for very, very small missions, they could start to pick up, but fundamentally, I think they can bring new capabilities, like very short takeoff and landing operations, for example, with these active, you basically fly an airplane with a very small wing and you get the low stall speed with active flow control. I think in that sense, it's actually, opening new markets and new opportunities for us, because the storage is always going to be the issue. As soon as you talk about the instrumented fuel reserve, you double the size of the storage, and it kills many applications. But it can be complementary, because the motors and the control, the power densities of these systems are quite appealing.
So Fassi, actually, Joel made the point that Canada punches above its weight when it comes to aerospace, and it certainly does in the case of Pratt & Whitney Canada and Bombardier, in terms of the position in the global market. Now, the Canadian government historically has supported the industry, but on a project or program basis, with individual manufacturers. I think you made the point when we were talking earlier that the recent shift in the government is to go to more multi-sectoral, where they are sort of doing much broader artificial intelligence, things like that. But if you want to do this Canadian branding of aviation, Canadian aviation products, Canadian aviation as being sustainable, as leading in sustainability, how do we get the government to understand that aviation, yes, a sector-wide approach, but how do we get the government to understand that aviation needs its own leadership, roadmap, identity, branding, because it's very important to Canada going forward?
Well, the first thing is they look at what you mentioned, what all the competing countries, what they're having. They all have a sector-specific strategy for aerospace. The second thing is that the industry in Canada is very well aligned. If you hear what Jean is saying, we are all together, whether it's at the Aéro Montréal, Chantier Innovation, or at the AIAC Technology Committee, we have all agreed on what are the 4 or 5 main technologies that we need to push forward to make aviation more sustainable in Canada. So what we need is a strong partner in the Canadian government to be able to demonstrate and have projects that we can work all together on and accelerate the moment where we can bring all this to the market. So it's really that will from the government to say, we're gonna remain a player in aerospace in the world, and knowing that the Canadian market is fairly small, so we are all geared towards export markets. So we need the Canadian government to step in and support demonstration programs. In our case, of course, we try to use technology also to make this demonstration more affordable. One of the technologies that are coming up are the drones. And there used to be technologies where we would have to put a flying vehicle to demonstrate the capability. But nowadays we can demonstrate it faster and in a more affordable way on drones. So there's several things that can be done to arrive in 2025 or 2030 with products and processes that will compete effectively with the rest of the world.
And I think one of the things that Europe's shown is that large demonstrator programs actually help you bring many more players in. They are more expensive, but you bring many more players into that demonstrator program. So Alex, I just wanted to ask you, how important is it to have a Canadian solution to this problem? And you know, the sustainable aviation fuel has long been advertised. It's a local solution. It's a global problem, but SAF is kind of a local solution. You do whatever you do locally, it might be different in different places. So how important is it for Canada to have its own ecosystem that is meeting this need?
Yeah, I think you set the table for that in the sense that we do need regional solutions because there are regional feedstock constraints when you come to SAF. Are you doing SAF from, if you do it from a bio source, is that bio source available in your region? Regions where that is not available in the required quantities. In our case, CO2 and renewable electricity are abundant in Canada, not abundant in many other places. So that's one of the abundant solutions that feedstocks that we have. And by using CO2, which is another abundant, unfortunately, solution, we can have together something that regionally has the chance to scale up a lot better with lesser bottlenecks and lesser sustainability issues than other solutions out there. But moreover, more than that is, I believe by taking it through this more regional approach where we can have our regional players working together, like Fassi was saying, working Pratt & Whitney. I mean, we could, SAF Plus Consortium is like that as well, allows us for us to study and to grow things based on the same principles at our scale, and ultimately for the rest of the world allows us to see more solutions appearing that are different, giving a chance for us to experiment and not get stuck into something that we could think it's a silver bullet when it's not. And I just want to give the example of ethanol for the automotive industry that was believed to be a silver bullet, and I'm sure a lot of people are looking forward to get out of it right now.
Well, thank you. I agree. I actually think we've the end of a monolithic solution to aviation or a monolithic approach to aviation. I think it's gone. We are going to see aircraft very narrowly defined for markets using different technologies. So guys, you've been fantastic. It's been a great debate. I have to wrap up here. I'll hand back to our organizers, but thank you very much.
Thank you.
you.
Thank you.
Thank you, Graham, Alexandru, Anna, Fassi, and Jean for being with us today. No doubt that our participants have learned a lot today. So everyone stay tuned as Aéro Montréal will host its third webinar on September 22nd under the theme Smart Procurement, Leveraging Commercial Velocity for Defense, organized once again in collaboration with Aviation Week. So we look forward to welcoming you in large numbers. On behalf of Aéro Montréal, thank you.
Thank you.
Bye-bye.
Bye.
Thank you, everyone.